After you have done your classifications and you have done your regressions, right? The next thing is you need to evaluate the model. So later on, when you run your own machine learning projects, you need to know, after you have picked the model, build it, you need to learn how to evaluate the model. And evaluating model for classification is actually not that hard. We are actually looking at two things, right? The actual values and the predicted value. The actual values are the values that you have observed, you have collected, you have gathered from the actual data sets. And the predicted values is the value that is provided to you from your model. You are using your model, you train your model using the observations data, right? And then after that, you use your models to generate the predicted values. Now, in terms of model evaluations, right, you have to be comfortable, yeah, just by looking at, true positive and true negative. These are the numbers that represents how well your model does, meaning uh, the correct predictions that your model has been able to perform. And something that's more tricky is actually false positive and false negative. False positive and false negative, a lot of times students will ask me, so doctor, false positive or false negative, which one is worse? The answer is always it depends, right? Let me give you an example. You must have heard of a story called The Boys Who Cried Wolf, right? Meaning that a boy was watching the farm. He's basically doing herding the sheep, like, yeah. And then every time he shouted like, "Oh, there's the wolf is coming!" And then the people got scared, right? And then people got scared, and then the adults came and helped him. And then when they came over, they realized there's no wolf, so the adult become very angry. And after 3 times of doing so, the adult got angry and not coming anymore. So this is an actual if you put it into machine learning cases, right, this is actually what we call false positive. I think of it like you have an alarm at home, right? Alarm system at home, to catch motion sensors. Are basically anybody who walk past your front door will ring. So if the alarm is too sensitive, and any single thing that walk past will buzz, right? A cat lah, a cockroach lah, a dog lah, your alarm will ring. Those are false positive. So what you decided to do is you are going to tune it down, so that it's become less sensitive, right? But when it's becomes less sensitive, then one day, even if an actual thief or burglar that come to your house, the alarm might not ring. Okay, so that's the concept there. So in particular case, right, we are looking at, will subscribers from telco A switch to telco B? So once again, true positive and true negative is the one that you don't have to worry too much. Yeah, just like survival bias. So those that predicted yes, they are switching it, and they did switch. Uh, yeah, too bad. Yeah, see you next time. And those that you predicted that is going to leave, but also going to stay, and they are staying also, right? These are our true negatives, so no problem. Now, among false positive and false negative, which one is more important? Which one you should pay more attention to? So, if those that you predicted that yes, they will leave our company, but eventually they did not, right? So it will that is false positive. So that is good. The one that is worse is you predict that these people will stay with you, right? They will not switch to other telco, but later on they did. Yeah, so those are false negatives. So in this particular case, false negative is the one that you uh, want to pay extra attention to. Now, in machine learning, right, there are two things, what we call precisions and also accuracy. Precision is a measure that measures the ratio between true positive and true positive plus false negatives. So meaning precision is to look at true positive over true positive plus false positive. So in this case, it's 63 over 90. Yeah, 63 over 90. Okay, so your precision is quite high in this case, meaning that those that you are predicted are sort of together. But precision only tell you one part of the story, right? What you actually care is your accuracy. Not only you want to be precise, but you also want to be accurate. So To measure accuracy is to use true positive plus true negative divide by the total number of cases. Okay, understand? Now, if this is a bit abstract, right? Let me just put it into a gamification model. So accuracy versus precision is accuracy is okay, our objective, right, is to hit the bull eye, right, to hit the center part. So the blue bull dart is very precise, meaning that every time you throw the blue color one can always hit the same spot, very precise, but that is not accurate, meaning it landed on the wrong place. The red dart is actually precise and accurate. So if you look at the definition, right, precision is actually help us to measure true positive over true positive plus false positive. So we want to make sure that this number is as high as possible. Yeah, we want to reduce the number of false positive in this case. Okay, so when you are evaluating your machine learning model for classifications, always aim for both precisions and also the accuracy. Okay. Now, what about forecasting? When you are forecasting, right, meaning that you are measuring the values. But don't forget, when you measure the values, right, you you don't have a ground truth anymore. You don't have a class, right? You don't have a class to say that or this is A, this is B. Meaning that there's no true positive or there's no true negative, false positive case. So you can only have a value. There's always a number of value. So what you can do is you can use this method called R square. All right, R square is a way that for you to measure the distance between your observed model and also your observed value and also your values that's from your predictions. And I'm not going into too much of the technical details, but you just need to remember R square is the metrics that you need to use. All right, and your job is to always the black color line is your model. Your job is to measure the predicted values from the model and the actual values that you have gathered from your observations.